At this point, we've made progress in making sure that the message a sender meant to send, which goes through packet form, arrives at the other end uncorrupted to the receiver. But if there is a good chance that packets like this are corrupted, that would also go for these acknowledgements or ACK packets that are sent from the receiver back to the sender over here. That is, what if this packet that we're checking whether it means acknowledgement or ACK, what if that one gets corrupted? Well, we could have the original sender, who is now the receiver of this ACK or ACK, send a message back to the original receiver, which is now the sender of the ACK or ACK, saying that I got a particular packet, and if that's not what receiver over here meant to send, okay, you can see where this goes. There would be some infinite regress of acknowledgements and acknowledgements and acknowledgements of acknowledgements. Well, we don't have to solve this problem completely, but we do have to make it much less likely. And a way we can do that is by having the sender and the receiver stay in a kind of lockstep alternating between two modes, 0 and 1. And that way, if the sender side gets a negative acknowledgement back that it misinterprets as an acknowledgement, or that got corrupted into acknowledgement, and it moves into phase 1, we can kind of detect that because the receiver over here, who sent the ACK, will be staying in state 0. That is, I've just taken the two nodes that we had before for the sender and split it into 4 nodes, so that when we successfully receive an acknowledgement, we go into waiting for application 1, and when that receives an acknowledgement, we go back into waiting for application 0. There's nothing magic about 0 and 1 here. It could be 0, 1, 2, 3, but just having 2 states is enough to get a useful amount of improvement. Meanwhile, the receiver is similar. It's waiting for a packet in mode 0. When it acknowledges a good packet, it moves to 1, and when it gets a packet there, it will acknowledge those and move back to 0. So you can see that when we send a packet from the receiver in our initial mode, we make a packet with checksum saying that it's for phase 0, whereas if we're waiting for the application in mode 1 here, we do the same sort of thing, but we annotate which mode we think we're in. And then on the receiver side, checking for corruption is also checking to make sure that that packet is for the phase that the receiver over here thinks that we are in. Now, I left out the ACK part of the diagram so far, and that's because it turns out that sending a ACK packet in a particular phase is the same as sending an acknowledgement packet in the wrong phase. So we just need one kind of acknowledgement packet, and we can use the acknowledgement packet in the wrong phase to serve as the ACK packet. And then on the receiver side, we're not really checking for ACK packets anymore. We're just checking for the case that the packet is not an acknowledgement packet for the phase that we are in currently. So if it's meant as a ACK packet, it'll have the wrong phase and it won't pass our test, and we'll treat it as an ACK packet. Or if the packet gets corrupted in some more general way that it doesn't look right as an acknowledgement for the current phase, then we'll just resend the packet and wait again for a proper acknowledgement.